Trigonometry Lesson 1 Directed Angle Part 2 The standard position of the directed angle. Each directed angle has a standard position. Okay? If what? If my angle satisfy two conditions. What's my two conditions? Look at this angle. What is the initial side? OA. Okay? My initial side lies on the positive direction of x-axis. This is a positive direction and this is negative. Okay? My initial side lies on the positive direction of x-axis. This is the first condition. Look at this angle. Okay, my angle here. My initial is OA. OA lies on the positive direction of x-axis. This angle, my initial OA lies on positive direction of x-axis. Okay, يبقى these angles, the initial lies on positive direction of x-axis. What's my second condition? Do you see vertex? The vertex here is the origin point. Okay, at point 0 and 0. The vertex at the origin. The vertex at the origin. يبقى then for any directed angle, satisfies the two conditions. Its initial side lies on the positive direction of x-axis and its vertex is the origin point of the orthogonal coordinate plane, then this directed angle in the standard position. Okay, like all this angle. But see to these angles. This angle, what's my initial? OA or OB? Do you see this arrow? Start from OA, then this is initial. My initial side lies in first quadrant. No, it is not on the positive direction of x-axis. Then this directed angle not on standard position. Okay, look to this. What is my initial? My arrow in this direction. Then the initial is OA. OA lies on the negative direction of x-axis. Then this directed angle not on standard position. Look at this angle. This arrow show me what is my initial. My initial is OA. Start from OA and round. Okay, my initial is OA. OA on the positive direction of y-axis. This is y-axis. Then my directed angle not on standard position. Okay, do you see my directed angle here? This is original. This is initial. Sorry. This initial lies on positive direction of x-axis, but the vertex not the origin point. Then this directed angle not on standard position. The directed angle in the opposite figure is not in the standard position because it's a vertex, not the origin point O. Okay, next part, equivalent angles. Let us look to these figures and notice something. When I draw directed angle in the standard position like this, okay, start from initial, round to OB is terminal side. Okay, this is directed angle. When I draw this directed angle and round or rotate from initial all this and stop at terminal OB. What I get? I get the same angle. It's the same. Okay? I round 1. I draw my directed angle, same directed angle, and round, then round another time. It is the same. Look at this. When I start from initial, round, okay, they are the same. This is directed, okay, I round once, then another time, I get the same angles. Then what we notice? Then we notice that if the directed angle in the standard position are said to be equivalent, I have many angles said to be equivalent to my angle, to my directed angle, when they have one common terminal side. Okay, this is the same terminal side for all. This angle is called theta. When I add to this angle theta, I round all this, I round 360, theta plus 360. In figure 3, what is the measure of this angle? This is theta. I round all this theta and 360, another 360. Then I add to my angle theta 2 plus 360. Okay, this is theta. Okay, I round in this side, then I subtract from my theta minus 360, theta minus 360, and this is theta. We round in this direction, minus 360, then another minus 360. Then the measure of this directed angle theta minus 2 by 360. All these angles are equivalent. All these angles are equivalent. Then if theta is the measure of a directed angle in the standard position, then the angles whose measure theta plus or minus 360, theta plus 2 or minus 2 by 360, and so on. Okay, for sure n is an integer. Okay, all these angles are called equivalent. Example, determine two angles, one of the positive measure and the other with the negative measure, having the common terminal. I have angle theta is 80. Then by an easy way, we add 360 to 80 or subtract 360. The positive measure 80 plus 360, then we get 440. Then angle 440 is equivalent to angle 80. My angle is 80, I can subtract 360, then equal negative 280. Measure angle negative 280 is equivalent to angle 80. Okay, by same way, this angle negative 200, I add 360. Okay, there are infinite number of the other positive and negative measure. Here I add 360, but I can add 2 by 360. I can add 3 by 360, and so on. 80 minus 360, I can subtract 360 one round. I can subtract 2 by 360. I can subtract 3 by 360, and so on. Another example, determine the smallest positive measure for each of the angles whose measure are as follows. First question, negative 50. Okay, negative 50 is a negative. Then I add 360, then equals 310. Second question, negative 210. Negative 210, I add 360 to get the positive. He wants the positive, then we add 360. Okay. Question 3, I have the positive measure. Then I need a positive measure. 270 minus 360 to get angle 110. It's a positive measure. Fourth question, negative 710. This is a negative, then we add 360. But if I add 360, I get measure more 360, but I want the smallest positive. Then I add 2 by 360. Okay? And you can add 360, then add another 360. Next, negative 800. We add, if you add 360, you get large number. Another 360, third 360, and then we add 3 by 360. Okay? 1110. Okay? We subtract, you can try it by subtract 360, second 360, third 360 to get the smallest positive answer. Okay? Next part, angle position in the orthogonal coordinate plane. Each directed angle has a position. How I know my position? First, let us remember when I draw x-axis and y-axis, here is 0 and here is 90 degree. This is 180 and this is 270. Okay? This part we named it first quadrant, and this is second quadrant, this is third quadrant, this fourth quadrant. Okay? The orthogonal coordinate plane is divided into 4 quadrants. Okay? The position of the directed angle determined by what? Determined by the planes of the terminal side. Where is my terminal? If your terminal side in first, then the position is first. When your terminal is in second, then your position is second. Okay? The position of the directed angle is determined by its terminal side when it is in its standard position. Look, this is directed angle in standard position. This is initial and this is terminal. My terminal in first quadrant, then the position of this directed angle at first quadrant. Okay? Here theta greater 90 and greater 0 and smaller 90. Look at this directed angle. This is initial and this is terminal. My terminal side at second quadrant. Then this is the position of this directed angle in second quadrant. Third, this is initial and my directed angle round. My terminal in third. Then the position of this directed angle at third quadrant. And then this is terminal at fourth. Then my position of this directed angle at fourth quadrant. Here is theta greater 0, smaller 90. Here theta, the measure of this angle, greater 90 but smaller 180. Here theta greater 180 and smaller 270. This greater here is 270, greater 270 and smaller 360. If my directed angle, its terminal lies on x-axis or here in y-axis, in this part, what we named my angle. If the terminal side lies on one of the two axes, then the angle is called quadrantal angle. It's called what? Quadrantal angle. The quadrantal angle, it's measured 0 or 90 or 180 or 270 or 360, or these angles are quadrantal. Thank you.